All right. So let's go ahead and finish up 2.7 and 2.8. And I'm going to change this to example 1 for 2.7, 2.8. But before I do that, I would like you to go down and do a summary on 2.7, 2.8. That was on proportions and using proportions in word problems. And don't forget to do your level of understanding on proportions and using proportions. So I'll give you just a minute to do that, and then we'll go up and use that extra box to do our example 1. Okay. So now that you've paused the video and went ahead and did your summary and example, let's talk proportions. So remember, when you're solving proportions, you're going to cross multiply. So if we take a nice easy proportion, 4 over 3 equals 8 over x, you might notice that you could take 4 times 2 and get 8. So 3 times 2 would be whatever number you're trying to find. And that is true. But when our proportions get more difficult, then we might need another method to solve. And for that other method, we're going to use cross multiplying. So during cross multiplying, you take your two numbers that are diagonal from each other, so 3 times 8, and you multiply them together. And then you set them equal to two numbers that are the other diagonal across from each other, so 4 times x, and then you go through and you solve that problem, just like you would solve a regular equation at the beginning of this chapter. So 3 times 8 is 24, and 4x, divide by 4 on both sides, and you get x equals 6. Pretty easy, right? Let's try a more difficult proportion. So skip over your summary and your level of understanding for proportions, and let's try a more difficult proportion. So in our more difficult proportions, you might have multiple terms in your numerator or denominator, and that will require you to do a little more work when you're solving your equation. So b minus 8 over 5 over b plus 3 over 4. So this is a second proportion that we're going to solve here. And you can tell that it is also difficult to automatically multiply something times 5 to make 4. So that part is going to be hard. But in addition, with your two terms in your numerator, it's very difficult to find what term you might need to multiply by, like we did up here, where you could just say 4 times 2. So here we're definitely going to use the cross multiplying method. It will be much easier to solve. So 4 times the quantity, b minus 8. Remember, fraction bars are grouping symbols, so that everything in the numerator needs to be in parentheses together. And then 5 times the quantity, b plus 3. And then we'll set those equal to each other. So number 1, making sure that you are multiplying the correct things together is important. And number 2, making sure that you keep those grouping symbols in there as you're working, because it's important to make sure that you multiply either the 4 or the 5 times both of those terms in the numerators. All right, so now we have a distributive problem, so we can distribute on both sides. 4b minus 32 and 5b plus 15. Now I have variables on both sides, so I'll need to decide, do I want to subtract 4 from both sides or subtract 5? In this case, I would suggest that you subtract 4b. And then I'm going to subtract 15 on both sides. That's going to give us our answer that b equals negative 47. Now you might be saying to yourself, well, how can I get a negative number? Well, that's certainly possible, because remember, if you have a negative number in the numerator divided by a positive number, that is a negative answer. If you have negative divided by negative, it's still a positive answer. So negative answers are not necessarily bad things here. Okay, so now that we've talked a little bit about solving proportions, we want to talk about how we can do those in word problems or real life scenarios. So my first one is going to be about similar triangles. So my example here, example 3 now, remember we started with 1 on the other page, is talking about two similar triangles. So if I have triangle ABC, similar, remember that's the similar symbol to DEF, And triangle ABC is kind of a bigger triangle, and triangle DEF is a much smaller triangle, then I can match up the parts of those triangles that are the same. So length AB is 10, length BC is 16, length DE is unknown, and length EF is 12. In this visual, you'll notice that side BC and side EF are the same kind of side. They're both the top left side. And then AB, sorry, top right, and DE are the top left side, so they should go together. That's going to help us write our proportion. So I'm going to put my two green segment lengths together in a fraction. So I might say 10 over x, and then I'll put my pink segment lengths in a fraction together, 16 over 12. There are a variety of ways you could write this proportion, and you could kind of mix up the numbers and letters and things like that. As long as the two numbers and letters that you put together still have something in common, then you are able to write a proportion with them. So I just want to go through real quick a list of okay fractions or proportions to write here. So these would all be acceptable proportions for you to write. Sorry about that. And they would all give you the same answer at the end. There are a couple not okay, and I'll show you those in a minute. So it would be okay to flip both of these fractions, x over 10 and 12 over 16. That would be okay. It would be okay to put 10 with 16 in a fraction because they're in the same triangle, the ABC triangle, and then x over 12. And then you could also flip that and do 16 over 10 and 12 over x. All of those would be acceptable okay proportions for you to solve. Ones that would be not okay would be if you paired two side lengths that aren't color coded together, or if they weren't in the same triangle. So you'll notice 16 and x are two different colors and they're in two different triangles. So that means they cannot go with your 12 and your 10. Okay, that's not okay. Likewise, putting x over 12 would not be okay. Oh, sorry, yes, x over 12 is okay. If I just flip those, x over 16 and 12 over, or 10 over 12, those would not be acceptable as well. So making sure that your proportions either are the same part of your shape, so the same side length on your shape, or that they're in the same shape together, that will give you all okay proportions for you to solve. All right, back to solving this one. So I'm going to cross multiply 16 times x and 10 times 12. And then I'm going to divide by 16 on both sides. And I'm going to end up with x equals 7.5. Okay. So again, in similar figures, the proportions are probably not very difficult to solve, but you need to make sure that you write your proportion correctly in one of those okay setups so that you solve it and get the right answer. You can also kind of check right here in this step when we cross multiplied. If you cross multiply any of the okay proportions, you'll see they all give you the equation 16x equals 120. But if you go down to the not okay proportions, you'll notice that those equations do not give you 16x. They might give you 12x, and that is not okay. All right, let's take a look at another kind of similar figure problem, and that would be example number 4 here. So this one's going to tell you that standing in the sun, there's a girl who is 5 feet tall and has a 3-foot shadow. A nearby building has a 15-foot shadow. How tall is the building? So for this problem, you'll notice that we are going to create two similar triangles. And with those similar triangles, then you're going to have, again, matching parts. So if I draw my girl and her shadow, this length is 5 feet tall. This shadow is 3 feet tall. Remember, the sun would be over here somewhere. Nearby, there's also a building. And the building shadow is 15 feet tall. So you'll see already that we have two triangles. If I go ahead and draw my sun rays here for both of them that make the shadow, right? Two triangles that match up. And you'll see that my heights match up in both, and then my shadow lengths match up in both. So when I write my proportion, just like I did in the similar triangles, I could do 3 over 15 equals 5 over x. I could flip those, or I could write 3 and 5 in the same triangle, in the same fraction because they're the same triangle. So if I cross multiply here, I get 3x equals 75, I think. Yes, 75. And then divide by 3, and I get 25 feet tall is the building. Okay. So there's your next similar triangles example. Okay. Our last example has to do with scales, scale models, scale drawings, etc. And for that one, we don't actually need a picture, but we're going to set up a proportion based on the information they gave us. Okay, so at a science museum, a model heart is 16 feet tall for a person who is 170 feet tall. What size heart does a man who is 6 feet tall have? So again, we don't actually need to draw a picture here, but we do need to match up our heart size with our height of our person in both fractions. So we have 16 over 170 equal to x, that's what we're trying to find, our heart size, over 6 feet tall. And just like we've been doing, we're going to cross multiply, and I'm going to get 170x equals 16 times 6. So my calculator, 16 times 6 is going to be 96. Then I'm going to divide by 170, and that's going to tell me that x is 0.565 rounded. And remember, that's in feet. So roughly half a foot tall, roughly 6 inches or so for your heart in a 6-foot man. Okay, so hopefully you can see that scale models are not that different than your similar figure drawings. You just don't have an actual picture to line up your items with. You're going to want to go ahead and just figure out what parts go together. So in this case, it would be heart size and the height of your item or your person. Okay, so that's it for proportions and 2, 7, 2, 8. So go ahead and give me another check on that and see how you're doing.